Hi, my name is J.C. Park. I'm from Dankook University, Department of Periodontology. I am the assistant professor and also I'm the chair of my department, and also I'm the ITI fellow. The title of my lecture today will be the digital approach for regenerative surgeries, navigating beyond the map. Before we move on, I'd like to clarify that I have no financial disclosure or conflict of interest. Ladies and gentlemen, we are living in the world of digital technology, and I believe that you all agree with this. What can we do using this digital technology? We can change our conventional way. As a lecturer, I teach the students in the classroom. I used to do that, but nowadays, sometimes I do not go to the classroom, but I show up on the presentation screen. And my students in the classroom, they log in into their YouTube account and using their smartphones, they watch my surgeries, which is lively broadcasted from the surgical operating room. Using the YouTube app, they leave the comments, they give me questions, and also they can communicate among the students. From my side, I see their questions on my screen, and I give the almost immediate feedback to my students. So, what technology do I need to do this high level communication, live broadcasting? Surprisingly, all I need is the smartphone with the internet connection. That's it. This is an example that I performed for a while ago for my live surgery session for my students, undergraduate students. So I would say that it is not the real high definition video, but considering the fact there is only 2 or 3 seconds delay, this quality is not really bad. I'm very satisfied with the quality. And the students can watch this video and they give me questions and I answer them, and during the procedures, I feel like I'm with them. The problem is there are 70 of them. I cannot literally can be all together in a very small operating room, but using this digital technology, I can be with them. So I said we are living in the world of technology, but I want to specify that actually it is 3A technology. Advanced. This is a very advanced level of the technology, but which is affordable. Sometimes it's free. And also it's so easy to use, so it's approachable for nearly everyone. So we are living in the world of advanced but affordable and approachable technology. So what do we do using this 3A technology? They allow me to do something amazing. As you see, this is a very small but beautiful lake which is in front of my school. Actually, this video was taken by myself. I bought a drone and I recorded this view just 1 week later. So I learned really quick because it's very user-friendly interfaces. The reason that I bought this drone was not to take the picture of my school, but I wanted to use it in the dental clinic. But unfortunately, a few years ago, an Irish father did exactly the thing that I wanted to do. This is downloaded from the YouTube. As you see, a father and son using the drone to extract his son's primary tooth. Do you see that the kid is dancing? We all know before the extraction, usually the kids are scared and they are afraid, but this kid is happy. And the primary tooth was gone just like that. So this is the technology. We are really afraid of many technologies because they will kill the humankind, they will take our future away. But it's important who is using the technology and how he or she is using that technology. That all makes the difference. So, how do you use your technology in your dental clinic every day? I would say everybody is familiar with the fully guided surgery using the surgical kit or cone beam CT images. Not 2D, not two-dimensional treatment planning, but 3D restoration. You can rotate and you can measure the diameter, the length, and you can change the location, you can change the path, depth, everything. After you are done with this treatment planning, your information is delivered to the surgical stent, which was printed in 3D printer. So using this 3D printer and the specially designed implant drilling kit, you can just continue with the implant drilling without the flap reflection and actually without looking. You just follow the drill through the hole because it supports the path, location, and even the depth. All of the information that you had from the 3D reconstructed images, it is delivered and transferred into that surgical stent. So this is the guided surgeries, and sometimes after we place the implant placement, if it requires the bone graft, we reflect the flap and we do the conventional GBL after we place the implant in an ideal position. So digital technology does not prevent us doing the conventional thing, but it also helps us to it better, quicker, and much more accurate way. So this is the digital technology that I think that everybody is already familiar, so I will not talk too much about this technology, but this is the result. After extraction, I have placed the immediate implants and multiple implants less than 30 minutes, and the final crown was delivered. And I would say that I should have done the contour augmentation, but although it is a digital approach, I could do the conventional GBL. In this case, I did not do, but I could have done it. So these fancy technology can be used in some different areas. What are the indications? How about if we use this 3D information for our educations? It can literally change our dental education. Actually, in 2015, a UK surgeon lively broadcasted his cancer surgery using the virtual reality. And this was the beginning. Nowadays, everybody is interested in using the virtual reality for medical and dental education. At that time, the quality was low, but nowadays we have everything that is required. The resolution, definition, and the tactile senses, and it feels so real. So the recent study tells us if we use this virtual reality to the residents, they perceive and learn the information 500% faster and better. So that's a substantial improvement in our education. So you will see this view as a very unreal situation, but these are 100 surgeons practicing the surgery using the virtual reality. So maybe this is the future of our dental school. But we all agree that this technology is expensive, so every student cannot have it. Luckily, Google Cardboard Project provided very cheap and approachable technology for us, which is called Google Cardboard, which is made from the paper cardboard. If you fold it and if you put your smartphone inside, if you wear them, if you move your head around, you can feel that you're actually in that location. So the motto of this cardboard project is bringing the students where the school bus cannot go. So for instance, we go to the moon, we go to the deep ocean, we go to the human body. So these things can bring us to impossible places. How about the operating room? If I bring my 70 students into my operating room, it will be impossible to observe. And literally, the oral cavity is so small and they will see nothing. But I have provided 70 Google Cardboards for my students, and using their smartphones, they had an experience of how the operating room looks like. And since then, they are learning about the surgeries, the non-surgical treatments, implant surgeries. Everything becomes so meaningful because They have been there. They have already the experiences. What do I need it? I need the VL camera. If you have a two-sided lenses, VL cameras are all I need. I just take it out and I record the procedures. And I don't need additional technology. Just download the video clip and upload it to the YouTube. That's it. Then the YouTube automatically stitches it, two images together, and make a 360-degree sphere. So your students can move around these areas and see what they really see in the operating room. The good thing about this virtual reality is, no matter how many times we show the pictures of the third-person view to the students, they learn nothing because their brain is not activated. But very surprisingly, if I show my students the first-person view and the same related brain area is also activated, the study tells us. So by watching this first-person view video and the virtual reality, the students learn just like they have really having a surgery or some treatments. Now we are moving to them from VR to AR, which is the augmented reality. What do I need? This paper box. It's called the merge cube. You just trim it and you fold it, then it's it. That's it. It's already ready. So this, take out the merge cube and put your iPhone, iPad, tablet, anything on top of this merge cube. Then the camera of your tablet recognizes that box, and then it overlaps these images, animations, and anything. So your students can rotate this cube, but it is cube, but on the screen, it just looks like the beating heart of a patient. Then you know the students will learn the anatomy, and their imagination expands because they had it in their hand. It's so real. So from this technology, we can move on to the next level, the real human-like simulations. Dr. Weinstock from Boston Children's Hospital, they have created the real patient-like simulator model based on the images from the real patients. So they do the surgery before, and then they do the surgery on the real patient. Why can we do that? We can do exactly the same thing. We have everything it requires. We have the image information because we take the cone beam CT before the sinus lift. And then we have the 3D printer. So let's utilize them. Send the CBCT images. This is the patient that I'm going to do the sinus surgery on the upper left maxillary sinus. And then we took the CBCT. From these images, we know that this area is bone is thin and this area is bone is thick and the membrane is thickened and all the information is inside my head, but I don't really see the 3D images. So using the rapid plaster model, we printed the CBCT images into the real human skull, and then with a little adding of the silicone inside the sinus cavity with the adhesive, we mimic the real Schneider membrane. I know, of course, it is not the real Schneider membrane, but it really feels like the Schneider membrane. We take out the drills, we create the lateral window. We can evaluate where is the ideal window opening, here or here. This area is bone is thick, this area is bone is thin. And we can correct our treatment planning. And then, after we create the window, we take out the instruments, and then we can practice the sinus membrane elevation. By doing this, we can prevent the accidents because we know the anatomy, which areas are flat, where is the median wall, and where are the septum, and we get all the information and we learn it from our body. And then we jump into the real patient. You know the results. It will be a little bit better, a whole lot better actually, because we have exactly did the same surgery in a model, in a simulator. So I want to call it as a sinus recon. The recon means that the soldiers going somewhere and then they learn about these territories and come back with the information. So it's called sinus recon. I think that this is a game changer for the training or education or for daily routines. After sinus surgery, how can we evaluate? How can we assess how we did? We take the immediate cone-beam CT again, and using the digital technology, we can color the area that was augmented. Then we can measure the volume and we can assess the location, and then we are learning from it. The amount of the bone was not enough, the location should be medial or distal, and then we learn and we practice better and better. And with the help of the digital technology, this is all possible. Now you might wonder, if we have a 3D printer, maybe we can print a bone. Yes, you're right. 3D printed bone. In 2015, Dr. Ross Perini and Professor Gianobili has introduced that, the clinical case of the early 50 male patients. The STL data was transferred into the polycarprolactone PCL scaffold with a 4% hydroxyapatite was 3D printed. A little PDL spaces and everything inside. And this scaffold was immersed in 0.5 milliliter RH-PTGF-BB, commercially known as the GEM21, for 15 minutes, filled with autologous blood. And then this scaffold was stabilized with a resorbable pin. Up to 1 year, there was no exposure, and there was a 3 millimeter of the clinical attachment with a partial root coverage. Not bad. Unfortunately, at 13 months, the scaffold was exposed and the scaffold has to be removed. But I think that this is a very good start to use the 3D printed scaffold for oral tissue regeneration. So maybe someday we will 3D print the bone and the PDL spaces, and these little pores will guide the PDL to grow inside and on top of the cementum or the root. You might wonder, this is too much far, and when can it be possible? So if it sounds too farther away, then how about this one? This is not a scaffold, synthetic scaffold. Actually, it is coming from the donors, human donors. It's called customized allogenic bone block. This is quite friendly, and the histology and the clinical results tell us quite satisfactory results. If you are still afraid of using these block bones, at least you can customize and 3D print only the outer shell, outer scaffold, just like we use the titanium meshes. It has been already 50 years that we use the titanium meshes, and we know how to deal with that, right? So instead of using the conventional off-the-shelf titanium mesh, but in this case, we use the customized 3D printed, patient-friendly titanium meshes. And it's called YXOS CBR. And the results using this technology already tells us a great results. The patient came in with a severe defect in the anterior lesions. There is no vertical or horizontal bone. The CBCT was taken, and the 3D reconstructed images, you can design the titanium meshes. If you want, you can make it a very small holes for future implants, then it will be the surgical stent. Otherwise, it will be just the conventional titanium meshes. So the results tell us a very nice regeneration in vertical and also horizontal dimension. So using digital technology in regenerative dentistry is at this level. How about conventional restoration? And I will say that they have already well improved using the digital technology, and especially intraoral scanners are very at the tip of the advancement. using these intraoral scanners, but there are many brands coming on the market right now. So my good friend, Professor Jiman Park, he has compared available commercial 9 intraoral scanners for precision and accuracy. And his recent studies too, he also compared again. He concluded that between the companies, there are some difference and deviation in trueness and the accuracy. But still, overall, these intraoral scanners provide very nice accuracy and trueness comparable to that the conventional impression taking. So, can we use this intraoral scanner for regenerative dentistry? Why not? This is a very great example. A patient came in, a late 20s male. He reported to me with multiple gingival recessions, and I performed the tunneling procedures. I created the tunnels, and then I took out the connective tissues from the palate. And as you can see, I do not do the sutures anymore. I take out this dressing material. This is not digital technology, but it's actually a new technology. That's why I introduced to you. This is a non-eugenal protective dressing material. You just take it out and put it on the palate, and it will stabilize and it will help you with the bleeding control. So easy. So I don't have to spend my time in doing sutures for the bleeding control. Anyway, using these grafted connective tissues, I put it under the flaps, and then I sutured. The healing was uneventful, but if you see closely, there are some things that I don't really like. The typical epithelial invaginations. Do you see that? Yes. This is before and this is the after. You will see that invagination. The patient doesn't recognize it and everybody's happy. And also for the research, I do the measurement using the metal measure, ruler, it doesn't matter. But where do we measure? Linear aspect, coronal and apical. Maybe one single point or sometimes 3 points. But all these measurements cannot really represent these epithelial invaginations or color mismatches or these volume discrepancies. How can we measure those parameters? And the intraoral scanners can do that. This is my patient, exactly the same patient. I scanned it using the intraoral scanners. And now you see the epithelial invaginations and the volume discrepancy and everything. So everything is stored, and every time my patient comes in for a checkup, I can take it out this information and I can do the comparison. So these intraoral scanners has wide open a new area for the periodontologist. This is also my colleague, Professor Lee from Yonsei University. He has compared conventional measuring of the keratinized tissue with the intraoral scanners. And also he has compared with the histological analysis. And he concluded that this digital oral scanner is more accurate than the conventional measuring, and also it has higher inter-rater reliability. So this is the animal study. So I have performed a clinical study. Using the intraoral scanners, I can scan the whole maxilla and mandible, and because this keratinized tissue is not line, it is the area, it is the surface. So using this instrument, intraoral scanner, I can scan the surface and I can measure how much keratinized tissue we have. So I hopefully present the paper in a near future. And also there is another way that I can use. I have created a new suture technique which is called a flap folding suture. This maximizes the buccal keratinized tissue on the buccal aspect, especially under the healing abutments. So you go in from the buccal aspect and you go under the lingual aspect, you come out and you engage the buccal flap again. So it starts with 1, 2, and go 3, and go in again 4, and then engage buccal flap 5 and 6. By doing this, this buccal flap is folded, especially if we do the paramarginal incisions, and these two silks will stabilize and push down the keratinized tissue. You may wonder about the vertical incisions, but after 2 weeks later, this is the result. Very nice, excellent healing is expected from this suture. So, if I want to measure the results coming from this suture, how can we measure that using the metal ruler? It is impossible. But let's say that we perform the same procedure before and after. This is the especially designed peak scan abutment. So this is some kind of a healing abutment, but you can use it for the intraoral scanner because it doesn't reflect the light. Anyway, I perform the flap folding suture, and then using the intraoral scanners before and after, I can compare how much keratinized tissue I have preserved. And by doing overlapping, superimposing, I can see how much keratinized tissue is folded and augmented buccally and coronally. So these digital technologies enable us. We used to take the pictures, which are flat 2D pictures, but now we have a 3D information. So it will help us to better see the situations and to better predict the future, and also to better compare with the past. Recently, I had a chance to visit the Da Vinci Surgical Robot Institute. And in fact, this robot, surgical robot, is only allowed for medical field. So I received a special permission from the company that I want to utilize it for the dental typodonts. So this is me working on the Da Vinci robot. With the two hands, I can control the robot arms, and with my both feet, I can also control the cameras, and I can do the bleeding controlling, everything. And with two eyes, I can see what's going on in a 3D with the perception, depth perception. So this quality was amazing. And this is the video that I'm doing the suture immediately around after 30-minute training. It was not really difficult, I would say. It was difficult. It was weird in the beginning, but after a couple of exercises, I get the idea how to play with this robot. So I believe that someday we all will be using this robot in our dental clinic. So it will be this way, or it will be this way, we don't know, but it will be our future. So when you go abroad, do you still use a paper map? Do you still use the sextant and then you analyze where you are? I don't think so. These 2D paper maps have critical issues because the Earth is round and the paper map is flat. So if you want to transfer 3D into 2D, there is always discrepancy. For instance, I used to believe that Greenland is bigger than the America or the Mexico, because actually from the map it looks like it's huge. But if you drag the size of the Greenland and drag it to near to the equator, all of a sudden it becomes smaller and smaller. It becomes the size of the Saudi Arabia. But if you put it on the North Pole, it becomes big and huge again. Why? Because the Earth is 3D and the map is 2D. Let's say that human skull is 3D, but if you put it onto 2D map, then the 3D skull will be crushed down and there will be a lot of distortions. That's why we prefer the digital technologies. Yes, this is the world of digital technology. If you open up the application, you are always in the middle, in the center of the map. That is called egocentric. how convenient it is. And also, if you type in your destination, immediately they give you the route A, route B, with the traffic and everything. So efficient. It saves me a lot of time, and I don't have to getting lost. That's the digital technology. But let's go back to our old conventional way, the paper map. We know there are distortions. We know there are some misinformations. But you have to find where you are, because it's not egocentric. You have to find where you are, and then just by looking hard into the map and by studying, you get to know the territories. And sometimes you hold the map in your two hands and you sometimes wonder, what is out there above this map? What is out there beyond this map? So these conventional maps, they make you think, make you imagine, and make you discover the new territories. I want to close up my lecture showing this little technique. It's called Adler-Meyer. The patient comes to me with a shallow vestibule and with no keratinized tissue. And if you move the lip of the patient, you can see that it is all movable and there is no vestibule at all. So the patient has a very difficulty to brush properly. So what do? This is a modified Adler-Meyer technique. We remove the epithelium and lift up the epithelium, and then remove the periosteum, muscle attachment, and everything, and this expose the bone. And the lifted epithelium comes down, and it covers the denuded bone. And without any suture, we just wait. And what happens? Before, after 2 weeks. Excellent healing. If you wait 1 year, this is the result. From the beginning, there was no shallow, all movable tissues, but now it is not yet keratinized tissue, but at least it is attached, and we have the vestibule. So this is a very old surgical technique, nearly forgotten, but we have rediscovered because we wanted to go beyond the map. The Alvin Toffler once said, the illiterate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. So ladies and gentlemen, this is the future, the digital technology. We learn the conventional dentistry. Maybe it's time to unlearn our old knowledge and relearn the new things. And I also want to challenge you, all open up the map and navigate beyond the map. Thank you for your kind attention.